All right, this is part 2 of the parabolic graph. So here we're going to be investigating what? The effect of A on the parabolic graph. Now, our new equation says y is equals to ax squared with the addition of A. So we want to know that this addition of A, which is multiplying with x squared, how does it change the graph? Hence, the word effect, right? So what are we going to do? First, we go back to our parent graph, which is function of x is equals to x squared. Now we are going to be investigating three x values, negative 1, 0, and 1. We know that when it's negative 1, our y is 1, our x, when it's 0, our y is 0, our y, when our x is 1, our y is 1. Now, what happens? Now we've got a second graph which is called g of x, whereby the a is what? The a is half or half x squared. So this is our a here. Now we want to know, how does this graph of half, right? How does this a change this graph of x squared? Now observe, on x is negative 1, we are getting half, whereas when x was negative 1, we had 1. Now if I just sketch something, let's say a Cartesian plane here, and when I was at negative 1 here, my y value was 1. And now when I'm having half x squared and I'm getting a value of what? I'm getting the value of half. It means that I'm still at the same point, but I'm in between. So meaning to say that this half is making your y value to be smaller. Let's observe. At 0, it's still 0, and here at 0, it was 0. Meaning to say that it's here. Both of them, they are found here. Then at 1 here, positive 1, x when it was positive 1, the y was positive 1. Meaning to say that we now draw here to say that, okay, we've got a positive 1 here, and our y value is what? Positive 1. Now here at half x squared, when we're having x value which is positive 1, we've got half. Meaning to say that we've got an answer which is less than 1, right? So the influence of A when it's a smaller number, because half is a fraction, right? It's making the values of y to become smaller and smaller. We observed it here. We could join these 3 points actually, the negative 1, the 0, and the positive 1. And this is the type of parabola which you would get. And you can see that the values of y, when it's equals to x squared, they are above this particular parabolic graph. So we can conclude that the smaller, as a gets smaller, the y values also get what? Smaller. So if you are having a smaller a, you must know that your y values are going to get smaller. That's when you're having the smaller values. Now let's observe bigger values. Here now we're having what? The graph which says h of x is equals to 2x squared. Now 2 is bigger than what? Here at function of x is equals to x squared, there is an invisible 1 here, and 1 is smaller than 2. Now let's observe. When we are at x is equals to negative 1, the y value that we get is positive 2. When we're here, when x was equal to negative 1, the y value that we had was 1. And 1 is smaller than 2. Okay, so we can see that this a has made the y value to be bigger. When it's at 0, it's also 0. When we are at positive 1, the y value is 2. When we're at positive 1 here, the y value was 1. So as the a gets bigger, we can conclude that our y values got bigger. So the conclusion, as a gets bigger, the y values get bigger. That's what we can draw. But let's see if that's true. Then I introduced another graph of j of x is equals to 3x squared. When x was negative 1, our y value was 3. Now let's not compare it with the parent graph, because already we know that the parent graph is smaller than 2. So let's compare when a is 3 and 3 is bigger than 2. We want to see, remember, so far we've concluded that the bigger the a value, the bigger the y values. So when x was -1 here, the answer was 2. And 2 is less than what? 3, right? 0, 0, when you multiply by 0, obviously you get what? 0. Here, when x was +1 on A, the y value was what? 2. And here, when x is +1, the y value is what? 3. So this 3 is bigger than this 2. And this 3 is bigger than this 2. Which means that this conclusion that we drew, that as A gets bigger, the y values get bigger. So we can say that the effect of A is that if your A is smaller, the y values become smaller. But if your A is bigger, then your y values become bigger, right? So that's what we do, and that's what happens. Also, I took the pleasure of what? Of plotting here, right? The function of x and g of x. So remember, when x was +1, y was 1. When x was -1, the y was 1, you can see. And when x was +2, y is 4. And when x is -2, y is 4. This is the function of x. Then we went to g of x. When x was a +1, the y is 2. And when x was -1, the y is +2. This g of x is the same as this one, which is represented where? Is the same as the one which is represented here as 2x squared. The only thing which I did is that I changed the name. Here it was h, there I wrote it as g. But we're talking about this one. Why am I saying that? Check. When x here was -1, the y was 2. And when x here is -1, we wrote that the y is what? The y is 2. When x was +1 here, the y was 2. And when x was +1 here, the y is what? 2, which is bigger. So why am I showing you this graph? I'm now showing you that these, remember, the parabolic graph has got curves, and now these y values which we're getting here, we call these the arcs. Because it's curvaceous, we call these arcs. So now, as your A value gets bigger, then the answers that you're getting, your y values, they get closer to the what? To the y-axis. They get closer to the y-axis. Check. When it was just y is equals to x squared, this arc and that arc, they are far away from the y-axis. But here and there, you can see that they're getting closer and closer to the y-axis. So you can also investigate on your own. You can use this one. J of x is equals to 3x squared. Definitely it will be more inside because 3, remember, is bigger than 2. If you use 4, it will be way closer. However, it will never touch the y-axis. All the values that you can investigate with, they only get closer to the y-axis. They never touch the y-axis. So in terms of this table, that's what the conclusion that we can draw. However, that is not only the effect of A on the parabolic graph. Here is the other effect of A on the parabolic graph, right? So what happens with here, right? Effect of A on the parabolic graph. Now, when A is more than 0, this sign is telling us that A is more than 0. What happens when A is more than 0? This is when we're getting values of A like half, when we get values of 1, when we get values of what? 2, 3, 4. Any positive numbers, they are bigger than 0. That's what is meant by this. Now, you must know the shape. So A also tells you about the shape of the graph. So when your A is more than 0, we call it concave up, which means a happy face. This is the graph which you get. This is what we call the concave up, which is a happy face. You can see that this guy is happy, right? This is the happy face. Now, not only do you get that, not only do we get to know the shape, but you must also know that here, if we use this, so these two graphs which I drew here, this is what we call the concaves. And what happens? We are saying that the A values were more than 0. Now here, if you check here where we're getting 0 here, this is what we call the minimum y value, meaning to say that when you are having a concave up, it means that you get a minimum value. So here, when we're at x is equals to 0, our y was equals to 0. And observe, from this 0 you go up here, you've got 1, we had 4. And this graph continues. Remember, the values of y keep on becoming bigger and bigger. So if your a is more than 0, you must know that you will have a minimum value, a minimum y value. That is what you get told by the value of a, right? Which is a positive a, right? All right. Then the reverse is true as well. Now, here we're not talking about a is less than 0. What values are less than 0? This is when you say you've got a negative half, you've got a negative 1, you've got a negative 2. So all the negative numbers, this is when you say that your a are elements of what? Of negative numbers till you reach negative what? Infinity. Right? So all the negative values, they give you a graph which you call what? A convex, which is, that was the reflection which I spoke about on the previous video. So this is the shape that you get, right? If you are having, so you'll be having y is equals to, let's say, negative x squared. It will give you, if you want to see the shape, go to the previous video, the first video on the parabola. It will be like this. Or when you are having y is equals to negative 2x squared, it will be shaped like this, but it will be closer to the y-axis here, right? So that's the a here is negative 2, right? So this is the type of graph which you get. All right. Now, what happens? Now, observe where the graph is turning for this y. Here it's turning on top. So here when you're at top, we are now saying that the maximum value that you can get is what? The maximum value which you can get is here at where it turns, you get a maximum value. Let me just refer to my notes here. You see, here I wrote about g of x was equals to negative x squared, right? So observe, at x is equals to 0, our y was 0. But at x is equals to 1, our y was negative 1. And remember, negative 1 is less than 0. Meaning to say that if I were to draw this, let me just do this here and show you and demonstrate what I'm talking about so that you can understand the concept of the maximum value. So we're saying that here our x is 0, so our y is 0. But when our x was a positive 1, then our y was a negative 1. Do you see that this is less than 0? And when our x was negative 1, our y was also negative 1. Now, let's go to 2. When our x was 2, our y was negative 4. Now, when our x is 2, our y is negative 4 here. And when our x is negative 2, our y is also negative 4 there. So do you see that if I'm to come, let's say at 3 here, and remember the equation is y is equals to negative x squared. Y is equal to negative, open bracket, 3 squared, which is y is equals to negative. 3 squared gives us 9. So I've got a positive 9 here. Positive times negative, it's a negative. Therefore, my y is equals to a negative 9. Do you see that as my x value is getting bigger, the y value that I'm getting is getting smaller? Meaning to say that if I'm to join this now, if I'm to join that, here as my x values are increasing, my y values are decreasing. Meaning to say that here on top here, this is the maximum. When we say maximum value, we are simply saying that this is the biggest value. Not in the world, but on this graph that we are dealing with. The y value of 0 when x was equal to 0 and y was equals to 0. For this graph of g of x, which is equals to negative x squared, the maximum y value was 0. So whenever you are having a what? whenever you are having a convex, you must know that you get a maximum value. I hope it makes sense. Let's meet on the next video. On the next video, we are now going to be dealing with what? We're now going to be dealing with a function of x is equal to ax squared plus q. What we're going to be investigating is this y-intercept. Q is called a y-intercept. And what kind of change will Q be bringing to the graph of this parabola, right? What we call the effect. If this video was helpful to you, please consider subscribing, liking, sharing, and commenting. Thank you very much.